So today's video is on a slightly different topic. Last week when I was scrolling through my X feed like I usually do, there's something that caught my eye. I saw a bunch of tweets about this DeepSeek OCR paper and I thought to myself, why is an OCR paper suddenly getting so much attention? I mean, OCR is cool and all, don't get me wrong, but it's not something that really excites a lot of people these days, mainly because we already have pretty solid models for that use case. So I decided to dig deeper, and as I did, I realized that DeepSeek OCR wasn't really about OCR. It was about something much bigger: compression, tokenization, and context limits in AI models. Now that's actually a very hot topic in the AI research world. Let's take a tiny tangent here so I can explain some of those heavy words that I just used, things like tokenization. So as you know, tools like ChatGPT have a limit to how much you can input. This is called context limit. The way these models work is that your input goes into a tokenizer, which breaks it down into smaller units called tokens, and each token gets turned into a vector embedding, because at the end of the day we have to do a lot of maths in order to tell you how many R's are there in the word strawberry. Right now tokenizers aren't very efficient, as in they have roughly 1-to-1 compression ratio. So basically one character equals one token. This is just for demonstration purposes, although these values might differ in real world. Think of tokens like RAM. The more RAM you have, the more things you can handle at once. Similarly, the more tokens a model can process, the more it can remember in one go and behave like a true agent. This is where DeepSeek paper gets really interesting. Instead of using a normal text tokenizer like all the other existing AI models, they use a vision encoder that compresses information 10 times better while maintaining almost 95% or better accuracy on the same kind of task. So if you have an input image with say 1000 characters, the vision encoder could turn that into 256 tokens, way more efficient than if you were to use a text tokenizer, because in that case you would get almost 1000 tokens, and that would bloat up the context limit of the AI model, and soon it will start forgetting stuff, and then the entire experience would not feel truly agentic. So as I was reading through this paper, it got me thinking, can I use a vision encoder in front of a pre-trained large language model to extend its context limit? Think about it. Instead of sending a text message directly to ChatGPT, if I could compress the text message in a better way by using a vision encoder, then pass it to ChatGPT, I could cram in a lot more information into it. So I decided to do this experiment myself. Now I need to tell you that if it was like 2 years ago, I would not have thought of doing such things myself, because I did not think that I know enough about AI to be taking up projects like this. However, now everything is open. You have models, guides, notebooks, even the coding tools themselves explain the concepts to you. I use Cursor to write most of the code, and in this project I needed a lot of heavy lifting from Cursor, Claude, ChatGPT, Perplexity, and even Grok at certain point. It's like back in 2015 when you were doing web development, it was a pretty hot thing and you needed to learn a lot of things in order to do web dev. However, right now, you don't actually need to study it. You just start with some project and that's it. And I really believe that this is the best time to be building in AI. Even if you don't know machine learning yet, that's absolutely fine, because 5 years from now, machine learning is gonna feel like web development. If you're somebody who's not into machine learning, I think you should give it a try. Anyways, talking about the project. Right now, what I'm trying to do is use a vision encoder. I've been experimenting with a bunch of different encoders. Right now, I've decided that I'm going to use Donut Vision Encoder on a custom dataset that contains images with text in them. I'm going to pass those images into the vision encoder. After that, I'm going to take the output from that vision encoder, pass it to a projector. The projector's only job here is to figure out how to connect the vision encoder with the LLM. In my case, I'm going to use Nanochat as my LLM. In case you don't know what Nanochat is, it is this very small open source model from Karpathy. And if you don't know who he is, you need to stop this video and go watch his videos first, because he is a legend in this game. He has been one of the founding members of OpenAI, XAI, and even Google DeepMind. So he is somebody you should really follow. Now, he recently released this very small AI model called Nanochat that you can train on your custom hardware and on a custom dataset and all those kind of stuff. This model has very small context limit. It has only 2K context limit, which means if you try to input something that has more than 2000 characters, the model will not give you an answer for that. So the experiment that I want to do after reading DeepSeek OCR paper is to take this model and try to extend the context limit of it without having to change the model architecture or train it on a completely new dataset. As interesting as it is not something that is truly novel. We have seen certain experiments similar to this one happening in the past. Specifically, one paper that comes to my mind is this Blip2 bootstrapping language image pre-training with frozen image encoders and large language models paper. This paper did something that I'm truly fascinated by. It took a pre-trained image model, pre-trained text model, added a query transformer in between, and was able to convert them into a truly functioning VLM. VLM are vision language models where you input an image and you can talk about that image or ask questions about that image. My take on this entire thing is that I'm going to use that image to extend the context of an existing LLM. I'm still working through most of this project, to be honest, and I know that there are a lot more details that I skipped in this video, but if you're interested in that, you can follow me on X where I post about that project every single day, sometimes multiple times a day. And do let me know if you want me to make more videos related to AI on this channel, because I myself have started experimenting a lot more than I used to, and I would love for you guys to jump into the bandwagon and just, get going with machine learning related stuff, because take my words for it, 3 to 5 years down the line, it's gonna feel like web development, and you don't want to start web development when it's already behind. Everybody is doing it right now. What everybody is not doing is building their AI models. Do that. Thank you so much for watching. Anyways, I hope that you like this kind of video. I'm gonna have to end this now, but I'll see you in the next one, I guess.